Go.
It's not what you do for physics. It's what physics can do for you.
I did not have physics-related relationships with that one.
I'm spinning in a chair.
Prepare for trouble. Make it 3.
No one ever notices me.
We're the Science Bros.
And we're going to teach you
The ways of physics.
First law states that an object at rest wants to stay at rest. He also states that an object in motion wants to stay in motion.
Newton's second law of motion states the amount of force I give in this ball is directly proportional to the acceleration. When I give it more force, it's still the same. Come on! Every reaction has an equal opposite reaction.
Really?
Yeah, Newton's law of motion. Remember? These two are both pulling the rope with the same amount of force, making the net force, well, 0. Now, with a stationary object, the force that Waylon is using to pull this thing, it's not as strong. But when a second person comes in to help pull this, as is shown, it's twice as much. So as you can see, the waves that Waylon and Kate are making right now are transverse waves because the motion of the medium, which the rope in this case, is transverse to the direction the wave travels, henceforth making it, well, a transverse wave.
There. Coach, I can't beat him. He's too good.
You need to use your momentum. Add more speed behind your punch. Now get out there.
Yes, coach! We got another half of the force equation?
No, what is it?
It's mass! Solid that is composed of many compact molecules. And as we add energy in the heat form, the ice melts, allowing the molecules to expand and to kind of move around a little more, you know? Furthermore, as we add more energy, that'll begin to evaporate into molecules moving freely that despairs, you know, just around in the air. As that's happening, get a little fun fact for you. There's actually a fourth state of matter. It's plasma, if you didn't know, obviously. And it's only accessible when gas is contained and is superheated. As you can start to see right now, the water is starting to bubble or boil, which is good because that means we're getting into the state of evaporation, which is what we want. Might take a bit though, so we'll give it a little time. Little fun fact for you while we're waiting. See this? This is Jello. Pretty cool, right? I know. Jello is a example of a solid substaining in a liquid, like other things, like mud, for example. You know. Yeah, mud. As you can see again, our thing is bubbling more, boiling, and yeah. The higher the so fun fact, because right now we're in, I think, a low elevation, but the higher the elevation, what?
We're at sea level.
Okay, we're at sea level, so remember that. The higher the elevation, the shorter it takes to boil, but it takes longer to cook things. Now, the shorter the elevation, the longer it takes to boil it, but shorter to cook it.
Coming back, now as the water is provoked by a little bit of a... You can start to see the smoke coming off the water. And as you can also see, we have less water than we started out with. That's pretty nifty.
As you can see already, evaporation. Truly a beautiful and wonderful sight.
That's not really beautiful, it's just steam.
Hey, shush it. It's beautiful.
And it's gone.
Just like you, homie.
Thanks, homie. So what you just witnessed was an example of a longitudinal wave. And Waylon is still demonstrating the longitudinal wave. Oh, congratulations, buddy. Alright, gravity is something that is anywhere, everywhere. It's everywhere in everyday life. As you can see, Kate is holding a bottle and a brick right in front of her. What we're about to demonstrate is an experiment that Galileo did a couple years back, not quite fully sure. What he did is he went to the Leonardo of Pisa, had a bowling ball and a softball, or just a small ball, and he dropped both of them from the top of the tower and concluded that both of them landed at the same time due to gravity. As you can see, we don't have a bowling ball or a softball, but that does not matter. The brick is heavier and the bottle drop them, please. Voila. There is your proof. Now, objects fall at 9.8 meters per second. Or if you want to round it to 10, that works too. This is for any object due to gravity again.
On that note, everything in the universe is affected by gravity, even our own oceans and planets.
Alright guys, so we're going to be explaining the Doppler effect. I don't know if you can see him, but there's a truck coming our way very fast. And so we're going to present to you, or sorry, more should say, show you how the Doppler effect works. Here is shown. As you can see, it's getting louder. And now it's quieter. The Doppler effect, my friends. The Doppler effect. Indeed. As Waylon pulls back on the rubber band of this slingshot, it builds up potential energy, which is then used when he lets go to make kinetic energy. Did you know that kinetic energy's formula is mass times speed squared? God, I'm so done with this video! Well, guys, what do you say? We are definitely the physics bros. Yep.
Okay, I think we're good.
Alright then, good.
God